Hello and greetings, everyone. For a really long time, partnerships between industry and academia has been instrumental in advancing research and knowledge, and also creating a skilled workforce. While collaborations between the industry and academic institutions and even tripartite engagements involving the government have been successful in many nations globally, there aren't too many collaborations to take note of in the Indian context, but things surely are changing. In 2019, a report released by the Ministry of Science and Technology, Government of India, titled The Framework of Industry University Linkage in Research, found that though industry and academia work in tandem, the lack of a clear policy is preventing optimum cooperation. The report determined that a strong industry-academia collaboration with a focus on innovative ideas and R&D investment can help increase research capacity and enrollments in PhD programs. Ladies and gentlemen, as the industry picks pace to introduce autonomous vehicles on our roads, they also acknowledge the increasing complexity due to sensors, software, and systems in these vehicles. Autonomous driving requires a diverse multi-domain workforce ranging from data science to control engineering to tackle this complexity. It also demands a larger workforce to design, implement, and most importantly, validate the systems and software to ensure safety and reliability. This increased demand also presents an opportunity for the burgeoning Indian engineering workforce. Nonetheless, there are multiple critical questions that we need to address. One, are we ready with a competent, trained workforce? What are the demands of industry leaders from graduating engineers to be industry ready? How is academia responding to these changes? How can the industry and academia collaborate for research in autonomous driving? And considering the Indian automotive sector's frugal engineering strengths and the quality of India's engineering education system, what are some of the key opportunities that the industry can focus on? These are a few critical questions we asked ourselves while curating this roundtable on a very, very important subject of the autonomous driving opportunity, building industry and academia collaboration. Powered by MathWorks, this roundtable is an effort to get industry leaders and academicians into one platform to deliberate on opportunities, challenges, and how industry academia can collaborate in the field of autonomous driving. And we're indeed honored to have with us 5 key leaders representing the critical stakeholders of the Indian mobility ecosystem. Please join me in welcoming Dr. Shankar Venugopal, Vice President, Mahindra Research Valley at Mahindra & Mahindra. He leads technology innovation for the automotive and firm services business and heads intellectual property and patents and knowledge management functions. He's also the Dean of the Mahindra Technical Academy, and he's extremely passionate about developing sustainable urban mobility solutions, and his current interest spans electric vehicles, connected vehicles, autonomous vehicles, and precision farming. We also have with us Ms. Latha Chembrakalam. She's the head of Technical Center India at Continental, a dynamic business leader with close to 3 decades of experience. She joined Continental in August 2021 with responsibility for engineering competence for global and local markets, focusing on automotive technologies that include autonomous mobility and safety, vehicle networking, and information business areas. Latha also oversees Continental Engineering Services, Artificial Intelligence, Architecture and Software, and Process Methods and Tools departments in India. Our third guest today is Professor K. Madhava Krishna, Professor and Head of Robotics Research Center and the Kohli Center for Intelligent Systems at IIIT Hyderabad. He has been directing robotics research there for more than 15 years. During his stewardship, the Robotics Research Center gained international visibility and has had the good fortune to be ranked second in Asia and within the top 30 in the world in robotics research. This can be attributed directly to the students who have contributed to its growth. Our fourth guest today is Ms. Pamela Tiku. She is the Chief Business Officer at the International Center for Automotive Technology. Prior to this, she was the Senior General Manager for Powertrain at ICAT since February 2011. Before joining this role at ICAT, she had worked as Deputy Director Powertrain, and she also was Deputy Director Technical at Natrif and Deputy Director Technical at SIAM. Prior to that, she was with Honda CL India and also started her career as an engineer at Rico Auto Industries. Our final panelist today is Ms. Rashmi Gopala Rao. She is the industry manager for automotive at MathWorks. She is responsible for strategic technology planning and rollout for the India region. Our focus is to understand the major trends in Indian automotive industry, engage with senior executives and industry bodies to foster the adoption of MathWorks tools in the megatrends of automated driving, electrification, and data sciences. She has 19 years of industry experience spanning across tier ones such as Bosch, OEMs such as Maruti Suzuki, and tool providers such as ETAS and MathWorks. My name is Deepangshu Sharma. I'm the editor of Mobility Outlook, India's first and only media platform that takes a holistic approach to the mobility ecosystem. And I will be the moderator of this discussion. Now, before we proceed with the discussions today, please allow me to introduce and welcome Mr. Sunil Mothwani, Country Manager, Sales and Service at MathWorks, for his welcome address. Sunil has been with MathWorks since 2008, from the time it started operations in India, and has more than 30 years of experience in sales of technology products for various industry segments in India, including automotive, aerospace and defense, communications, semiconductor, medical devices, and industrial automation. Thank you, Sunil. We truly appreciate MathWorks' support in putting together this roundtable. May I now welcome you for your initial remarks. Over to you.
Yeah, thanks, Deepangshu. And we are very, very happy to be associated with Mobility Outlook in conducting this roundtable on the topic of automated driving, how industry and academia can collaborate together. It's indeed my honor and pleasure to welcome and thank all the panelists for their consent to be part of this discussion. We are certainly looking forward to a great discussion from this esteemed panel that represents the entire ecosystem of all the stakeholders in automotive industry in India, I would say. And we couldn't have asked for a better thought leadership than what we have today in this panel. So thank you all for taking your time out and joining us today afternoon for this event. This is the third roundtable that we are doing on the topic of automated driving. The first one also happened to be with Deepangshu. So thanks, Deepangshu, for helping us with this. The idea or thought behind doing such roundtables is to see how the thought leadership in India can come together and discuss ways and means by way of which we can accelerate the pace of innovation in this emerging technology area like autonomous driving. Now, when MathWorks started, 35 plus years back, we started with the theme of accelerating the pace of engineering and science by building tools that would help scientists and engineers do their research work and come out with innovative or bring their innovative ideas to reality in some ways. And we continue on that mission, both with the academia and industry. Across the globe, if you see, we have more than 1,000 plus universities, actually more than 5,000 universities using our tools. More than 1,000 plus universities have what we call as campus-wide licenses. And in India, we have 250 plus universities who have this campus-wide license, which means every student and every teacher in these universities has access to our products. The entire idea is to equip students with the industry standard tools that get used for research and innovation. So with this, we are helping academia in some ways. Of course, with industry, we continue to collaborate. We also collaborate with academia, and Professor Madhav Krishna is one of the persons from IIIT Hyderabad with whom our development team in Hyderabad is very well engaged. We learn a lot from industry leaders like Conti, and Mahindra. We learn a lot from government organizations like ICAT in terms of what is expected from a tool vendor like MathWorks to help this academia industry collaboration. Okay, so certainly looking forward to a great discussion from this panel on this topic. And we would be very happy in any ways if we could facilitate this kind of collaboration. Some of the things that we are doing right now, and in this ecosystem, there is one another piece is the startup ecosystem or the incubation centers that both academia and industry bodies are supporting in some ways. And we are collaborating with many multiple education institutes. Actually, most of the IITs, IISc incubation centers have access to our tools today under our incubation program. We have tied up with Niti Aayog, a government body, on the Atal Innovation Mission to support government's Atmanirbhar initiative, uh, tied up with uh, STPI for supporting all their incubation centers. So in a way, trying to bridge the gap between academia, industry, and the startup ecosystem to ensure that all of them have access to the tools that help accelerate the pace of engineering and science. So thank you very much, Deepangshu, for giving me this opportunity to welcome everyone, and thanks to all the panelists for their time once again. Back to you, Deepangshu, for starting the discussion.
Thank you very much, Sunil. Okay. I mean, the coming together of Mobility Outlook and MathWorks, like you mentioned, Sunil, is a result of our common objective and interest in spreading knowledge around these key subjects, be it advanced driver assistance systems and autonomous driving. Now, while we have in the past focused on ADAS and what is needed to create a roadmap for ADAS in India, this time around the focus is on, as the subject suggests, is on building collaborations between the industry and academia to meet the opportunities around autonomous driving. Now, we roughly have about 75 to 80 minutes, and to ensure a meaningful engagement for the given duration, I would like to break the discussion into 4 to 5 rounds. At this stage, I would also request our delegates today to actively participate in the discussion and ask questions to our panelists, and I shall take them up in the final round where we engage with all of you. So in round one, I would like to welcome each of our panelists to make introductory comments on the subject of the discussion. And I would request you all to limit your comments to a maximum of 2 to 3 minutes so that we can proceed in a structured manner. To start with, let me invite Dr. Venugopal for your initial comments on the subject today.
Thanks, Deepangshu. I think it's very important for us to look at electric mobility along with connected and autonomous features. That's when we'll be able to realize the maximum benefits. So we are looking at the convergence of electric, autonomous, and connected, all the three technologies, each of which is fairly disruptive in nature. Now we are imagining the convergence of these three powerful technologies. So that way it's a real mind shift. And we need to all really take a break and reimagine what are the possibilities when we start working in this space. Because there are so many things which were thought impossible. Now it is possible with the convergence of these three technologies. So the first thing that we need to do is let go of all the past assumptions and the constraints that we have worked with, and really take a fresh look at things to say how we can reimagine and do things. Having said that, it's not easy because you need to pick up a lot of new skills to do impactful work in this space. And I'm sure each one of us would have just specialized in one area, say a mechanical engineering or an electrical or electronics or computer science. Whereas what it takes to work in this space is expertise in all these areas. So very rarely you would find somebody who is equally good in all these engineering domains. So the biggest challenge for me as the Dean of the Mahindra Technical Academy is how to quickly reskill our engineers so that all our 3,000 odd people at the Mahindra Research Valley are equally comfortable with the mechanical engineering, electrical, electronics, and the computer science part of it that they need to come together and work in a cross-functional team. This is the first level. The next level is developing a product that is ideal for an Indian market, making it robust enough to work under a variety of conditions in India, and also keeping the cost low. So just because we are using a high-end technology, it should not add to the cost. It should be an affordable product. These are some of the next level innovation challenges that we need to focus on towards doing this. So I'm very eager to hear more from the other experts in this panel. So I'll stop at this stage. Sure.
Thank you, Dr. Venugopal. Very, very important points right at the start. You talked about convergence and the need for everyone to come together as we walk towards the future. Ms. Latha, I'll come to you for your initial comments on the subject. You'll have to unmute yourself, please. You're on mute. Yes.
Yeah. Okay. So thanks for that beautiful introduction, Dr. Venugopal. So I also kind of agree that the automotive sector is changing rapidly. And when we look from the OEM space as well as the technology companies, a lot of them are developing technologies which are in the automated, connected, electrified space. And each of them are kind of redefining the future of transport. And over the past few years, coming to the discussion for today, the advanced driver assistance system or ADAS, it has been gaining significant prominence, I would say, in the global automotive sector. And when we are looking at even the business figures, we were talking about maybe 32 billion in 2019 and continuous growth of around 11% to 12% CAGR is what is being expected. So you can imagine the volume of work which is coming in this sector. And we have this increasing awareness on the vehicle safety ratings and the decreasing component cost due to the extensive application of maybe the cameras, radars, lidar, etc. All these will be major growth drivers for the ADAS market. And as rightly told, we will not be able to focus on one technology. It is always going through co-creation by collaboration. That is where the world is leading to. And when we talk about whether it is artificial intelligence or data analytics, cloud computing, 5G, any of these, we cannot kind of separate it from each other. All these things have to coexist when we are talking about the new areas. And on the whole, the driver assistance systems makes the traffic safer. And I would say in Continental, it is kind of an essential element of what we call as a vision zero. But what we also need to look at is that to leapfrog towards this faster adoption of ADAS, which we really need to do also, we need to build a kind of an ecosystem. And this ecosystem, which is comprising of the OEMs, technology companies, the government bodies, R&D, academicians, institutions, I think the whole set of people have to come together to make it happen. And only then it can be made happen because we are talking about a pace which is much different than the past. And it starts with the first step through increased collaboration with academia, I would say, which is building some frameworks together, nurturing ideas, and exchanging the expertise that we have. And we are kind of particularly working on this research in scenario perception, and this would really help in the safety towards the pedestrian, bicycles, animals on road, protection from the potholes. These are some of the Indian scenarios also. So as we progress, I think we also need to look at certain different country scenarios, different other topics, which is kind of specific to India as well, when we talk about the innovative products that we need to do for India. So we strongly believe that through the partnership with the academic institutions, we would like to support three key strategic pillars. And one is the technology advancement. Second is creating an industry-ready talent pool. And the third is enabling an open innovation in the ecosystem, which is very, very critical. And I think this kind of a partnership that makes the future mobility concept a reality is very, very critical. And this is not value add just for a couple of partners, but as for the ecosystem as large. And as rightly Dr. Venugopal told, I think it all has to come together if it has to happen. This is not a standalone game anymore. I think many parties have to come together, collaborate to make it happen. So that's my initial view on it.
Thank you. Not a standalone game anymore. And three key pillars that Ms. Latha talked about: technology advancement, of course, in ensuring that there is an industry-ready pool of engineers who come up, and also focus on open innovation. Professor Krishna, I'll come to you for your initial comments. You'll have to please unmute yourself. Thank you.
Yeah, thank you. I think a lot has already been told by Dr. Latha and Dr. Shankar. So I think from a purely an academician's standpoint, I think the space has, even from the standpoint of what I would call as computer science, or navigation and computer vision, which is the area primarily I have been focusing on. There is a steep domain curve for students, like if you are having undergrad students joining after +2, there is, while they are pretty savvy with embedded systems, they can put together pieces of embedded hardware and get things going. I think that kind of skill set we see more. But I think autonomous driving is getting together. There's a lot of things at the level of math itself, which is needed to be understood, right? So, for example, the interplay between computer vision, lidar data, and fusing them, and navigation algorithms, which have a lot of backend optimization methods, like analytical, functional optimization methods, and to be able to deliver trajectories on real time for a road scene and things like that. This involves a rather steep domain curve before the students can start attacking these problems. So this is one thing which I think in academia we need to reorganize the coursework such that the students are ready to go, maybe even by the second year, or at least by the third year, beginning of third year, so that they can spend 2 years working on these problems, which is then, like they have a mature or a reasonably mature understanding of this this area. And this, of course, I'm talking it from the point of view of a particular area, which is more computer science. But I believe similar issues exist even within the mechanism or mechanical engineering, electric vehicle space, and probably also in the embedded systems and electronic space, right? So this, I think, could be the need of the hour, is to appreciate the problem space and appreciate the algorithms and the backend tools which are needed for this problem space. And how do we quickly let our students come to this, to a point where they can attack these problems. I think this is what I think is possibly, I would say, the awareness and understanding of the space from an academic standpoint. Thank you.
Thank you, Professor Krishna. We will, of course, come back to you to understand and dig a little deeper into what would really make students ready for the industry of tomorrow. I'll come to you, Ms. Tikku. Your initial comments on industry-academia collaboration, specifically with autonomous driving in mind.
Thank you, Deepangshu. I think Dr. Venugopal, Professor Madhav, Krishna, and Latha have very clearly mentioned that this is a new science, basically. And we need to understand the criticalities and the nuances of this technology adoption in Indian perspective. Even in global perspective also it is, but very typically for Indian perspective. One, we need to understand what our local requirements are. Secondly, our readiness and maturity of the technology availability in the country, and maturity of the consumer to accept the technology. That is also very important. You talked about industry academia collaboration. I would like to say that industry academia collaboration in India is I'll be very critical, is not at all there. So if we talk of having innovation and technology development in partnership with industry and academia, I don't see that happening in a big way. There might be happening industry academia collaborations, small technology development in silos. But if we talk of countries like Germany and US, they have large industry academia collaboration. They develop technologies out of universities, and then they get implemented in the industry across. While in India, we don't find that kind of ecosystem for development of technology in India, innovation for that matter. We are not able to develop. India has become a country of manufacturing and supply, but we are not, value-added economy. We are not creating IP, intellectual property in India. And when you talk of autonomous vehicle, it's a multidisciplinary science, wherein mechanical engineering, electrical electronics, sensors, computer science, AI, data sciences, all are integrated in this. So if we talk of ecosystem, neither are our academic institutes geared up to impart that kind of training to the students who are going to be working in the industry, and hence we don't have an output from the academic institutes for the industry readiness of these engineers of the future or these technologists of the future. We also don't have a very good network of research institutes in the country, wherein we can understand what research is being undertaken in which institute, and we can pick and choose. For example, a lot of research is happening in space and defense areas, which where India to a larger extent is self-reliant in certain areas. Why can't those technologies be disseminated to other industries? You can have a trade-off from one sector to other sector. So the researches happen, the innovations happen, but they are limited to a specific set of people or industry. So I would say that the government has also realized that this is a big lacuna in Indian economy, because the economy is still dependent on technology outside India. We still have to look for, I'm sorry, there are people sitting here who are representing large technology companies on board. We're still depending on technologies from outside India. We don't have core India-based technology development happening. So government's mission of this Atmanirbhar Bharat Abhiyan is a step towards that, to have India self-reliant in technology development. We should have innovation happening and developing an ecosystem of innovation in India, which is a miss there. So while baby steps have been taken in this step towards this direction, for example, the technology platform that the government has launched, and ICAT has also put up a technology platform called Aspire, wherein it is expected that industry poses their problem and there will be solution providers coming forward and giving a solution. But we are not seeing that traction happening. By I think we find there's resistance from industry to open up to talk about their problems. And hence, since they don't bring out the problems, there are not people who are willing to come and work for that solution for that problem. So we might need to take certain steps towards this direction. And this kind of ecosystem cannot be developed overnight. It will develop, but if it's started, then slowly, I think another 5-6 years time, we can find a similar ecosystem or a environment of innovation and development and research in India also. So India should now become a value-added economy rather than a non-value-added economy. That's what I will say. So whether it is skill sets at college level, skill sets at the industry research levels, academy industry collaborations, the startup activities that have happened are kind of building up that kind of ecosystem slowly in the country. They have created a base, so there is a confidence level of developing technologies locally, and people expressing their confidence in adapting those technologies also in India is happening. So I'm sure that the things will change. And with the autonomous vehicle and electrified vehicle, we have seen, we never expected electrification to happen like this in India. We are seeing it's just happening like this. We all thought, oh yes, electrification will happen 5 years, 10 years down the line. It's caught up like a wildfire actually. Everyone is now into electrification. So I'm sure that things will improve, and this industry academia collaboration for technology development will enable India to achieve the goals of self-reliance.
Right. Thank you, Ms. Tikku. Very strong, yet very, very pertinent points. And I'm sure our panel would like to respond to some of the points that you've raised today. But before that, I'd like to invite Rashmi for your initial comments on the subject.
Thank you, Deepangshu. I'm very delighted to be part of this discussion. It's a topic that's very close to our hearts at MathWorks, industry academy collaboration. So for those of you who probably don't know MathWorks, I'll take 30 seconds to introduce MathWorks. We are a tooling company that helps the automotive industry to essentially build systems, build software, work with data, apply AI use cases on, let's say on various use cases and so on. And we are in a very unique position, I would say, because we work with both these spheres of industry and academia on a day-to-day basis, right? We get to see the challenges, we get to see the demands, we also get to see the synergies. Pamela ma'am, there are few, I agree, but they are present in silos, and even if sporadic, they are there. And we also see the potential that, you know, these two spheres can hold if we were to collaborate together. So Sunil said in the beginning that the vision of MathWorks is to accelerate the pace of engineering and science. And we know very well that academia is that bedrock for tomorrow's engineering and for tomorrow's innovation. So we are very deeply invested in seeing how we can bridge this gap between industry to academia. And I'll talk a little bit about what initiatives we have taken a little later on in this discussion. Now I heard Latha and a few others say that the technology in AD is, we are really pushing the envelope here. When we talk about deep learning and AI, when we talk about processes like continuous integration and continuous development, when we talk about dealing with big data, integration on cloud. So all these topics are essentially new to a engineering audience in automotive, which is essentially control systems driven, right? But we believe if we have the right talent funnel behind us, this can also be a great opportunity. And in terms of opportunity, I would say that for regulatory bodies and for OEMs, it's a great chance to use technology to make our roads safer. And for technical centers and for service providers, it's a chance to bring home more work to India and hopefully also move up the value chain. And then, of course, we have this very vibrant community of startups, not to forget the challenges and the opportunities we have in homologation. The map providers, they also have a huge opportunity here to map India with more definition, high definition maps and so on. So really it is the coming together, as you all said, of all these players to make AD hopefully be adopted like we are seeing EV. It happened, you know, faster than we expected. And my hope is with ADAS already seeing the light of day, AD probably has a fair chance too in the Indian automotive system. The need of the hour, like all of you said, is collaboration. And Deepangshu, I believe that probably small steps like this is the beginning of one such. Look forward to the discussions here, and hopefully we continue to collaborate on this topic. Thank you.
For sure. Thank you, Rashmi. Like Ms. Tikku said, we may be slow, but that doesn't mean that we can't catch up, right? So I will go to the second round of this discussion, which essentially I'm going to focus on how much are we really aware of the opportunities, of the potential, and what is the kind of skills that we are prepared with. Dr. Venugopal, if you look at, when we look at Mahindra, for instance, with the latest product, of course, Mahindra has introduced what it calls level 2 autonomous driving features, right, with the XUV700. Now, how do you assess the awareness about the subject among people in general, and what needs to be done to make them more aware of autonomous driving?
Sure. The awareness is steadily growing, but definitely there is a mindset that this is all very high tech and it will take some time for us to learn and start working in that space. So we are trying to bring down that barrier by making these learning much easier. That's what we are trying to do at the Mahindra Technical Academy. One thing that I took inspiration from the way the whole autonomous vehicle technology grew was from the DARPA challenge. So I thought, why not use innovation challenges and competitions to accelerate the learning? So we internally throw these challenges open and invite teams to submit ideas. And then the teams who have submitted the ideas come for a very focused training, so that the whole training is enabled such a way that they can build a proof of concept for their idea, which is around autonomous vehicle technology. So that way, it's not a classroom training. It's all very hands-on. So as they learn, they are able to apply it and build something and test it. So that we found it to be very effective in bringing down the barriers and making it easy to learn. And our own journey started from a slightly different in a direction. We started with semi-autonomous tractors, which is a very different class of problem. And this we started maybe about 3-4 years back. And a lot of valuable learning. So a tractor may look like a relatively easier problem as compared to an autonomous vehicle on the road, but it brings its own challenges. So there was a lot of learning, and which we could effectively bring to the other products and domains too. But the biggest challenge was when you did the proof of concept, the price was in terms of lakhs, it was 2 digits. And then you are told that unless you bring it to a single digit, it's a product targeted for the Indian farmer. So farmer won't be able to even touch it if he can't make it affordable. So we realized that the technology is there to do the job, but the real focus for innovation should be to pick and choose the right combination of technologies, which will be robust enough, at the same time keep the product very affordable. So that's what gave us the initial orientation towards picking the right technologies. And we are still learning. Every day we are learning a lot in this space, but it's been a very, very satisfying journey so far.
Right. Thank you. I mean, of course, developing technology, but also ensuring that that is done at the right cost.
And using competitions and innovations to accelerate the whole learning. So once you bring that competition and a prize and things like that, people really get into that mode of learning. Very effective, that is.
Right. Correct. Ms. Latha, I'll come to you. While awareness, of course, is an important factor. Now, building on the opportunities that AD offers to a market like India is also equally important. Now, what are the specific skills that autonomous driving requires, and why is it important for the academy and industry to focus on upskilling with respect to autonomous driving?
Yeah. So what I would say is, coming from the Indian perspective, Indian being an emerging market, and also I would say laggard from the ADAS adoption, there are many technologies that would get imported to begin with, and that's a fact. And for the time being, most of these technologies and software which work best in the global market would get adopted probably only the premium segment cars in India. And when we talk about automotive, we are not talking only about passenger cars, like Dr. Venugopal mentioned. We are talking about agricultural and other industries as well, or other components as well, right? So in order to drive the volumes, it is clear that we need to be at the forefront in customizing the solution, and this would be whether it is a low-cost sensor or a software adaptation. And as I mentioned earlier, there are also the country-specific local needs that we have, like probably an animal detection or a pothole detection or the auto rickshaws and the kind of a traffic discipline we have. The Indian environment conditions are different, which means that we need to have very, very different kind of innovation that we need to implement here. And we should also have it as really robust, high quality, safe, affordable, and all these things. It is clear when we talk about robustness, safety, quality, and other things. It also comes as a price. So the challenge for most of us is basically to look at how do we really bring down the cost, and what are we talking about this low cost solutions, or I would say, I can't tell it a low cost, but what are the kind of best cost solutions that we can bring into the market. And when we look at the talent pool in India, the positive point is that the Indian talent pool is quite suited for the development of ADAS technologies. And when we look at probably some kind of surveys which we have, I think I was reading somewhere that in 2021 we had around 880,000 students enrolled in com science engineering discipline in academic year 2019. And this is one of the primary reasons where the GICs are setting up in India. And every year you can see that more and more GICs are coming in. And the modality what we work is that we have tied up with a lot of institutes. For example, Continental has tied up with IIIT Chennai. Basically, we have joined hands for advanced research in machine learning. So IIIT Chennai, with its known capability in machine learning and the bio-inspired neural networks, will contribute to the ADAS business, that provides drivers and passengers additional safety, obviously, right? So this collaboration, we have a interesting project code which is called Neuromotive. This will aid Continental's long-term strategy globally towards the Vision Zero, which is the future with zero accidents. So there's a lot of innovation and ongoing improvements of the existing components and system, which is for the Indian market, which we can do. And there are also 4 different academic institutions, including the IIT Delhi, then different IIITs and so on, where the collaboration has rapidly helped us to evolve in the technology area. And we also have to probably think a little bit different that, how do we make this upskilling, reskilling, side skilling, I would say, a little bit faster, because that's the kind of the need of the hour. And maybe like, Dr. Venugopal told, probably the conventional way of having a classroom session is not at all enough. So we'll have to look at different ways, having certain hackathons done. Maybe we'll have to look at crowdsourcing done in a different way. And as I mentioned, we have to actively engage in this high synergy collaboration with research institutions, and we will have to look at how do we get these brightest brains of the country in the Indian academy together. That's actually something which we need to do that. And there are different modalities of cooperation which are, to be explored. I would really agree with Ms. Pamela that currently the industry academic collaboration is at a I think it can drastically improve, whether it is internships or student projects or consultancy, tech talk, faculty mentoring, different instruments. But what I have experienced in the last couple of years is that over the time, these kind of engagements, what we start, these kind of investments, what we start, grow into strong symbiotic relationships. And that can really help India as a country. And when we look from the multinational perspective, most of the parent companies, they look at India as a country where you have a huge innovation potential. And if this can be brought into, I would say, to a greater height, there is a huge opportunity for India as an organization, whether we are talking about all these technologies like artificial intelligence or data science or IoT or whatever. I think it is something that we can build. But the question is that, is just the speed at which we are moving at this point of time for such kind of a disruptive technology, is it enough or no? My answer is it's not enough. So we really need to accelerate. We really need to probably think a little bit out of the box and look at how do we maybe strengthen as well as accelerate these collaborations, and how do we leverage the ecosystem and the talent pool what we have in India in a much better speed. So the skills are not rocket science for sure. Yeah, they are very different from what it was in the past. But how do we adapt it quickly? That's going to be the success of India for the future.
Wonderful thoughts, Ms. Latha. Ms. Tikku, I'll come to you. I mean, just picking up from what Latha talked about, right? We need high synergy collaborations, and the speed of that collaboration has to be in a manner that we sort of are able to match what happens globally, right? So when what's your assessment of the current state of skilling, if I may ask, as far as AD is concerned, and how do you view the opportunities in India? What can ICAT as an organization do to ensure that this speed is sort of taken up?
Deepangshu, ICAT as an organization, I feel, can play a very important role of catalyzing the adoption of these technologies and developing skilling for these technologies. One, we have a very strategic advantage of having an infrastructure wherein we can, create training tools and modules and develop skill courses and impart training to people. And secondly, as I said, we are also creating an incubation center. So we can incubate these young engineers or startups and handhold them in developing certain technologies. We have partnered with MathWorks and other simulation tool suppliers who are going to provide these tools actually free of cost to these young innovators, and they can play with it and they can experience this. And maybe out of 100, maybe 4 or 5 will become successful, but rest will definitely gain out of this experience of using these tools. So that experience will not go waste. That will be utilized by the industry, because if they are not successful in developing their own product, definitely the skill sets or the learnings out of these tools will help them in doing their jobs in industry wherever they can go. So we are going to create also an innovation academy, which is under Aspire, that we are going to set up, wherein we want to create special, modules for training for these areas where you don't have courses available. We can tie up with institutes. We can tie up with institutes like MathWorks, and also industry. For example, Latha talked about, how they have engaged IIT Chennai and IIITs in developing certain modules or technologies. So we can partner with industry, academia, and bring up those modules there. So we are in a strategic position because we are not a manufacturer of any technology. We are kind of a neutral body, so we can play a role of bringing all these stakeholders together and bringing out certain training modules, skillings, and also specialized handholding for such technology development. ADAS is a very complex technology. It's not purely mechanical, it's not purely electrical. So there is electrical, electronics, computer, AI, internet, everything. So all mixed together. It's going to be very complex science, basically. Sure. And you don't have people ready-made available to understand this science. You'll have to develop them over a period of time.
Sure. It's indeed very heartening to know that ICAT is setting up this Innovation Academy, like you mentioned, and that's good news for the industry, all stakeholders put together. And I'm sure the industry will sort of reach out to you for any possible collaborations that they can talk about. Rashmi, as a simulation partner, MathWorks, of course, works with several organizations. You did mention that in your initial comments. Now, what are some of your observations, if I may ask, from what you have seen working with industry partners and academic partners, of course? Yeah.
Sure, Deepangshu. So I'll probably highlight a little bit about how we see the industry in terms of, what it looks at today, what is the need of the skills today. I'll go a little bit deeper so that hopefully if there are academicians and students in the audience, they also benefit from our experiences as we work with industry. So the first thing I think was articulated very well so far, that it's not one science, right? So the need of many of these organizations is what we call sort of a T skill set. So they basically have the breadth of the domain. They are able to understand these different domains of perception, localization, planning, and control, and go deep into one domain. So if this is something that can be incorporated in academia, where even if they're going deep into one topic, the basic understanding, let's say, of this application is given, I think that would basically help. Another area that we are seeing is around basically the system understanding and and going a little higher than the individual components. And this we say play out very differently in AD when it comes to the as compared to the other domains. We see OEMs wanting to go deeper into components, deeper into software, almost like a tier one. And we see tier ones actually want to rise up and understand more about the system level understanding of how these things come together. All in all, irrespective of which customer segment we're talking about, there is a need for a system understanding, which I think is also something that engineers of the future, or reskilling as we call it, should incorporate. A little bit on the software development. So far, I spoke about the systems development. When it comes to software development, although there are a good amount of workflows, especially in ADAS, and as we go forward in AD, emerging workflows, we still see some scope for improvement when it comes to productivity, when it comes to, let's say, efficiency, and driving the development costs down, which hopefully also develops the product costs down and help, in adoption of this technology. I'll just take a few examples. So including more automation, for example. So when we're talking about labeling of camera or LiDAR or, other sensor, the images, if we can have automation as a part of that, it will dramatically improve the efficiency. Having virtual test benches, something that, we are speaking with Pamela ma'am as well, which can be used by academia to teach the concepts, as well as by industry to test, design their systems before they actually go to the hardware and before they actually go to vehicle prototypes. Another interesting observation in AD is that there is an amalgamation of tools out there. So AD development today requires the combination of many of these softwares to come together to basically achieve the AD stack, to achieve the AD functionality. We have efficiency losses when we try to do these integrations. So as an industry, as a community, we either have to fall back on standards or invest some efforts so that the efficiency among this is basically improved. Better integration platforms, maybe, if I can say it that way. Also, map providers, I think skilling there is essential so that we are able to, as a nation, build better maps, which is critical basically for adoption of this. How do we homologate these systems is another topic that we need to think about. And I think there's skilling there as well. For organizations that have been doing this for some time, one thing that has changed maybe when compared to a few years ago, I think Latha mentioned this, is that we are suddenly seeing the need of scale. It's a sector that's growing at 10-12%, as you know, Latha told us. So how do we basically scale this across vehicle platforms? How do we scale this across a different set of engineers is a problem that industry is looking at and that we need to think about. So these are a few things that we observe that basically is the need of the hour. I've spoken about the observations, Deepangshu. I'll take 30 seconds to also talk about what we are doing as an organization to do that. So we basically follow 3 pillars, if I may call it that, to address what we are seeing in the industry. One is we are investing for workforce mobility. So how do we do that? We basically, along with our product, are providing a lot of reference examples. So for example, an AEB feature or a traffic jam assist, there are already examples that tell you basically how this feature can be realized with various components coming together. The next piece that we are doing is investing heavily in simulation. And the third piece is to help you to write better software and to include automation. So this was a little bit about what we are observing in the industry, Deepangshu.
Sure. Thank you. Thank you very much. Very pertinent points, Rashmi. Professor Krishna, I'm going to actually club 2 questions for you. So the first question is, considering the developments that we see in the autonomous driving area and also the future requirements, right? What are some of the skills or concepts that you think are important to be introduced to students today to ensure they're industry ready once they graduate? That is one. And secondly, when we're talking of preparedness, right? How is academia really approaching a multidisciplinary domain like automated driving? You are on mute, Professor.
Oh, sorry. I would. What was your first question?
Okay, I'll just break it down into two separate questions. Sure. One is, I wanted to understand, when we look at the developments around this area and the future requirements. Now, what are some of the skills or concepts that you think are important for students to be imparted to students to ensure that they're ready for the industry once they graduate?
Right. Yeah. So I think, if you look at autonomous driving, and I have primarily worked in the computer science part of it, right? So which I think involves the perception part, like how does an agent on the road understand the scene around it? And this perception can happen through computer vision, through LiDAR, through radar, and the various kind of sensors. So, and once the perception is done, you also have the action space, right? How does the agent respond to this? What it perceives, and as the agent moves, how does it understand where it is in the situated world? So there are a lot of courses today, which in IIIT we teach mobile robotics, we teach computer vision, we teach deep learning, and a lot of our students have actually made a big mark in industry in India, abroad, right from Facebook AI Research, OpenAI, Drive.ai, and in India in MathWorks, in Siemens, and in Ola, for example. A lot of my students were recently hired in Ola Autonomous Driving Group. And just as a response to what Pamela ma'am had said, like in IIIT and many of the research centers in IIIT are continuously funded by industry. I mean, like all the Robotics Research Center, which I have been directing or heading for the last 17 years. Today, most of our funding is through industry, and we work with industry and they continue to work with us. So they have never left us and gone. A project is completed, then they would like to work with us further. I'm not sure if what we are doing is directly going into a particular product, but I think that it is certainly helping them. And the help is coming because of the quick understanding of the problem space itself. Through our curriculum, I think by the end of second year or early in third year. So the problem space in this area of autonomous driving or computer vision, the bunch of problems that are there in this space is understood. And the math which goes behind it is also needs to be understood for a student to develop algorithms And we have to understand the space is heavily research dominated. Like, a lot of innovation happens. A lot of companies are publishing in top forums like CVPR or ICRA, IROS, NeurIPS. So these conferences are now populated by the companies all over the world, right? Even MathWorks had a paper in a conference which is pretty high profile. So we want students to be able to appreciate these research, what's being told there, and be able to quickly develop this algorithm and code it, to prototype code. And here, as Rashmi was saying, you have a wide base to select it. So what optimization solver would you use? Would you use PyTorch for it, or would you use JAX for it, or would you go with SciPy for it? And then there is what are the various ways you're going to bring the various software modules and put them together and solve this problem. So in our courses, typically this is the coursework is centered such that all these tools also come into play when they solve a problem, right? So the course is typically consists of many projects which involve a lot of development of algorithms and bringing together of all these software together. And so I think that kind of what you call training or exposure is I think enabling people at least not to get scared of what is thrown on the student is in a position to understand the broad spectrum of problems. He is also able to understand what's the know-how behind this problem, and is also competent to say, well, I can do this particular problem on my own or with a team. And I also know what tools or what software or what kind of coding skills that I need to get to the table to do it. I think this is covered through the coursework and also through our constant engagement with industry in terms of research projects and collaborations. And also, like the way Dr. Shankar Venugopal told, we also participated in the Mahindra Rise autonomous driving competition together with MathWorks. And that brings in a lot of added spice and speed to this whole structure. I think this is one thing which I'm not sure if I answered your question, or was it like, that's maybe my answer to the first question.
Sure. I will now move to round two, which is essentially about preparedness, right? How prepared are we as an industry, as academia, to take on the challenge of this multidisciplinary technology that we're talking about today? So, you talked about the need for proficiency in different subject areas, when we're talking of really building or sort of preparing students to be industry ready. Now, how do you what are the changes do you think, Professor Krishna, that you might need to have to bring in to ensure that such a system, such a technology is approached correctly?
I think so. The exposure to the problem needs to come very early in the curriculum, and in IIIT, our curriculum is such that by the end of the second year, students are aware of the problem space, and not only in autonomous driving but in various other research disciplines, and the availability of also the hardware. If the university is organized in terms of research centers, and wherein the students are automatically going to faculty, and there is a peer group which is working on this problem. So in IIIT, and I believe this is true for all top universities in India and many other universities as well in India. So the structure is organized in terms of research center, and where the research center works on various problems in this space. There are students, undergrad, PhD, and students are working in this problem that gives a lot of peer group and discussion that happens. And the research center is funded also by collaborations which are happening with the industry itself, and they come in with their problems as well. So this model, which is actually there abroad, which is I think has led to what we see out there, is also is pursued now in Indian academia. A lot of our third year, fourth year students are directly working on industry projects. So for example, with TCS, we develop code and then we give it to TCS, and TCS integrates this code with them, and then they give it back, and we have a meeting together with the TCS research team on one side and our team. So we have weekly meetings with industry. Same with MathWorks. So wherein there is a constant movement of code and technology between the research center and the industry, which is happening, which is regularly happening, and then this into this ecosystem. We are having our third year and fourth year students getting part of this ecosystem.
Okay. Dr. Venugopal, I'll come to you. And what I'd like to understand from you is, one, your approach towards making that these engagements between yourself and the academia work. What are the typical challenges? And do you think there could be, in the future, when we look at core research versus application-based research, how do you see that growing in the Indian context?
Sure. So we have talked about the technology, the complexity of it, and also the need for making it reliable and affordable in the Indian context. So it's very obvious that no one group can do it alone. So definitely collaboration is very clear, very straightforward, the need for collaboration. When there are multiple parties involved, some from industry, some from academia, some from government research labs, there is always a possibility of a lot of repetition and misalignment. All these things can happen. This is what makes people worry a bit and stay away from this and try to own everything and do it within their four walls, which is actually not working. So to really get over this concerns that people have and make this large-scale collaboration possible, one thing that is needed is to have a roadmap, a very clear technology roadmap. The roadmap for India is going to be very different from the roadmap for the US or the Europe, because we have the opportunity to leapfrog some of the intermediate technologies and directly go for the latest. So that opportunity is there. So we need to all come together. For example, I have seen ICAT doing a lot of this, bringing people together and looking at technology roadmaps. They have portals where they post problems and invite ideas. So an organization like ICAT can actually lead this kind of effort, bringing industry, academia, and government labs together to build a roadmap. And once that is done, the government can use this roadmap to channelize all the research funding, so that as a series of projects are funded, the technology will grow along the roadmap and become practically viable. So this roadmap can typically be because the technology is growing so fast, maybe we should look at a 10-year technology roadmap and then say what we want to do in 3 years, 5 years, and 10 years. That level of granularity. Maybe it will take a few rounds of ideation to arrive at that. But if you're able to do that, I think that will bring a lot of coherence to what we are thinking and what we are trying to do. I think this is a great opportunity before us to bring all people together, right from ideating and building this roadmap, and then driving all the research such that it's aligned to the roadmap. This is what I think will really make the whole thing work.
Right. Great suggestion. Ms. Tikku, how do you respond to a suggestion like that? I mean, through Aspire, of course, you're inviting the industry to sort of collaborate and others to come in and help the industry, right? But this whole suggestion about creating a roadmap for the industry, can someone like an ICAT take that initiative forward?
Thank you, Deepangshu. I think since you are aware that under Aspire, we have created 18 sub-boards. So each sub-board has been given a mandate to create a technology roadmap for their own areas. For example, there will be a technology roadmap for ADAS implementation. There will be a technology roadmap for hydrogen economy implementation, roadmap for, what should we do near term, mid term, and long term technology development. As Dr. Venugopal said, we have asked, but unfortunately, we are not getting the right mass of people to come and collaborate and define this roadmap. We are not getting active participation from industry as to what is industry that they want to do. And government is willing to fund. I'm telling you, government wants to fund. They have huge funds allocated for technology development. Unfortunately, industry is not coming forward and asking us, come, we want to develop this technology and you collaborate with us. And this is where we are finding our hands tied up, and government asking us, why are you not bringing the projects from the industry? We are asking industry, the government is willing to fund the technology development, and we are caught in between two separate entities, each having their own expectation, but we are not able to converse it. I think that with the rollout of PLI schemes for automotive sector, for battery technology, and also there is the capital goods scheme phase 2, which is also getting notified shortly. There is also a FAME 2, which is already notified. So industry can take this opportunity wherein government wants to fund. Industry should come forward and identify technology area. We can only become a path or a mode to get this collaboration done.
Right.
80% of the funding government is willing to do. Industry only has to put in 20%. That's it. But we are not getting the right kind of mass for people to come and join us. We have been asking industry leaders. Also, I find one of the big challenges that I find is that people who are participating in these sub-boards are basically working level people. They are not the decision makers. So unless and until the decision maker comes into the picture of defining this roadmap and mandating these people that please go ahead and develop this technology, this is not going to happen. So we need a top-down approach in this case, wherein the industry leader pushes their people, go in and tell ICAT to develop these technologies and go to ministry, get the funding done and execute it. We are not able to, we find ourselves, challenged how to help it. I was part of one of the industry academia initiatives, which was called Core Group on Automotive Research, which had started way back in 2003, 2004. Yeah. With great effort, with great challenge, could we make people come on board and, Mahindra and Tata come and talk about common technology development. It took us at least n number of meetings. We had academic institutes, we had all research institutes, because it was led by none other than Principal Scientific Advisor to Government of India, Dr. Chidambaram. And there were people like Dr. Kasturi Rangan and all on board of that core group on automotive research. But what we did, we could only do 3 projects. That's it. After that, it did not. So government can do some bit of push on getting certain things started, kick-started, but it should have its own inertia to move forward. Government cannot be, pushing industry to come forward for do technology development. Industry should find value in developing technology locally in India rather than being dependent on technology always outside India.
Absolutely. So, Ms. Tikku, clearly, here's an open invitation again for everyone in the industry to come forward. I mean, the government is willing to do its bit, right? It's been asking the industry and the academy to come forward, take what is available and create. And that's where collaborations start, right? And like Ms. Tikku said, collaborative automotive R&D started in 2003. So we're talking about almost 18 years later, and we're still discussing the opportunities that industry and academia have to collaborate. I'll come to Latha on a very important subject, and that is essentially to do with the availability of talent, right? I mean, what level of work do you still need to do to prepare young engineers to take up work that you're doing at Continental once they graduate out of college? What level of gap do you still find?
Okay. Yeah, so I would say, just to answer in one sentence, I would say really a lot of work. Yeah, at this point of time, to really get an industry-ready engineer is next to impossible. Okay. And here I'm not talking about, as all of us know, it's a complex technology. There are a lot of different elements to it. So I'm really not even talking about somebody who knows the entire technology, which is impossible, because actually, as I mentioned earlier, the whole technology is moving towards a space where it is always a co-creation through collaboration. You might not find a mechanical engineer doing a mechanical electric, and everything is, every stream is kind of coming together to collaborate. So we are not even expecting that somebody knows the entire thing when they come. But what is kind of missing is, it's a lot of theory-based, approach which is done in most of the universities. If you look at the curriculum, it is a lot of theory-based. So maybe after the second year, third year beginning, we will have to really look at, and I think this is also a lot of initiative that we need to do from the industry. We cannot tell that universities have to take it up. But I think, to look at maybe a kind of a joint curriculum development, to have certain electives which are being taught by the industry expert. Maybe we can have some of the faculty development done by industry expert, having the faculty sitting maybe in the that's something which we are proposing to 2 or 3 education institutes now, that, why don't you send your faculty to our labs, let them also understand, so that you don't have to retrain every time. So we have to probably look at a very, very different approach. And I would like to come back to one point, what Ms. Pamela told, why are the industry people not coming and collaborating for this? So I think most of us are used, it's a lot to do with the mindset. I would be a little bit provocative here, because I think we all have been used to being successful alone, standalone entities being successful in the industry. And now we are getting into an era where standalone, we are not able to succeed. And it has to be collaboration, and it has to kind of working without boundaries, that, the seamless integration of academia, industry, research, everything has to happen. And in India, we are still not there with respect to the mindset. So I think it all, again, it starts with the leadership mindset, which we have to look at. The second thing is that how does the industry enable? So do we have some kind of a structured framework? We are currently now working on some kind of a framework where we talk about, internships with them, the kind of, what kind of research topics are there? How can we integrate our industry problems and get it solved through academia? But then there are a whole lot of other open issues which come up, right? Which probably we need some other intervention. For example, if there is an IP which is created, we need to actually look at, the government has to establish probably a law permitting a joint IP ownership to incorporate, whether it is a startup collaboration and an academia project, how does it actually do? So if these kinds of things are there, there will be an increasing corporate interest in skill as well as monetary investment, and allow India to accelerate its IP ownership in a new research area. The second thing is that, there are initiatives, but there can be actually more plug and play incubation hubs, which are there. There are actually few of them, obviously. But I think we need a little bit more involvement from the industry in these kind of innovation hubs. And as I mentioned, whether looking at an industry problem to get solved through a hackathon or a crowdsourcing and other things, being mentored by industry leaders. I completely agree with Ms. Tikku that mostly to the working level people who sit in these panels, but we need to have the industry leaders and the strategists contributing to what could be the roadmap and what is realistic, and not dragging projects maybe for years together, but have a certain definite plan, looking at what are the frame conditions, what we have in India, and contributing. So I think this is something which we need to change. And maybe the ask from the university side is that, more than going into a very theoretical kind of approach, can we look at, problem solving? Can we look at certain mini projects and others where you solve industry problems, and not, the writing thesis is good, but I would also like to see, kind of a demonstrators coming out of the colleges, something which is live, where people can relate to it. And, those kind of people are much more hands-on and industry ready when they come. And I would say that unfortunately, we don't have too many of those numbers coming in now, and it's quite disappointing. So I think it's a lot of work to be done from both parties. Yeah, and we will have to look at what are the government initiatives which are there. And we need to develop a kind of a much better platform where we can collaborate. Because as I mentioned earlier, this scaling up of this technology in a short time is critical for India as an economy, because this is a great opportunity for the talent we have in India. And we will really miss the bus if we are not able to scale it up fast. And the only way that we can do it is through this collaboration by using academy. And we have a huge amount of talent in the country, and it has to be effectively used. And a lot of work to be done, I would say.
Sure, sure. I'm also looking at the watch. We are at 4:15. We've got effectively 15 minutes to go. So what I'm going to do is dive deep, straight into our our next round, which is the focus here is on collaboration, right? I mean, Ms. Latha, you talked about various aspects, and all of us have been discussing in terms of what is needed to be prepared, right? That is one. But how do we really make this work, right? So what are some of the global best practices that we can adopt to ensure, let's say, meaningful collaborations between the industry and academia? There is an intent, yet things don't seem to happen. So what are some of the steps that we must take to ensure that this sort of leapfrogs, like we've said, but starts in the right earnest? Ms. Latha, I'll start off with you.
I mentioned, first of all, this kind of a framework, and from where does it have to start? It has to start from the industry to communicate what is the need of the industry itself. So I think we are very poor in that. And that is why probably the roadmaps are not getting ready, because we are not even communicating what is the requirement, what is the kind of a framework, what we need, what is the ecosystem that we need, what is the support that we need. So the strategy leaders have to come together and define this kind of a framework. And probably, like Ms. Tikku told that, they already have some projects and milestones there. We may have to populate the information there to take it forward. The third thing is that from the industry, we should have a much more stronger collaboration framework, which involves, for what topics do we have internship? What is the kind of IPs that we generate? Which kind of research projects can be given to the academia? How do we bring in academia as well as research institution together? So these kind of, some kind of a guidelines have to be evolved with all these things. And we also have to discuss on how do we influence the curriculum of the university. That is very, very important. As I mentioned, moving from a more theoretical to a more industry-oriented approach. And which are the topics which are there? Because when we really look at, if you just Google out for the skills, it will just simply tell that it is C++, Python, MATLAB, and 3 or 4 or 5 skills which is mentioned. But that is not industry readiness, right? When you're talking about it is concept, it is system integration, it's a whole lot of other concepts. So how do we really integrate these concepts along with the skills in the curriculum, and how do we really form center of excellences? And the center of excellence is not headed by only the industry, the COEs, which are maybe powered by the industry, but where we have very strong collaboration from the academy and research institute. That actually should be established. So we will also have to come up with a list of what are the kind of COEs that we need to establish, and what kind of topics do we need to discuss there. And this kind of a structured roadmap will actually help us to take things forward.
Thank you. Dr. Venugopal, what are your thoughts? How do you, one, ensure that a proper framework is created? Two, how is that framework communicated across the industry and the academia? And third, who really takes the initiative? Who takes the onus of leading it?
Sure. So I have 2 points in response to this. The first is the pace at which the whole technology is evolving is really fast. Okay, the autonomous technology we are talking about is growing exponentially, and the price of this technology is falling exponentially. So the LiDAR, for example, which was about $70,000 in 2012, we are talking about less than $1,000 today, which is a 98%, 99% drop in price. So when technology is growing exponentially, we should not be thinking incrementally. We should also think exponentially. So the kind of problems that we define to collaborate and solve should be not 2x or 3x improvements, should be 10x and 100x improvements. So it's very important for us to think exponentially and define the right problems and target them when we look at collaboration. This is very important. So that problem itself should be such that it inspires and motivates us to stretch, think out of the box and come up with things, because technology is capable of delivering it. Only we have to think at that scale. Second part is, how do we make this collaboration really work? because the industry guy is sitting in an industry environment where things are moving very fast and he has quarterly deliverables. And the academic professor is sitting in an academic environment where he's looking at long-term research, guiding students, publication. These are two different worlds. So we thought how we can bring this together. So I'm going to share something with you which actually worked for us, which many else also can try. One is to create mini sabbaticals where we brought faculty from the universities to spend time with us. We gave an immersive environment, made them work as part of our product development team for a couple of months to get the heat of it, how it is to build a product that really goes out, what all it has to go through. When we are doing this parallelly, we also sent some of our chief engineers and COE heads to IITs and IIC to teach a small short-term course and come, so that they can see how that environment is. This exchange of people for short duration also helped us to bring these two people to a level where they can understand each other's perspective and define the right problem, which will be equally exciting for both parties, come together and work. So one is about the problem, which should be a 10x and a 100x kind of problem that we should define. The second is give this exchange, cross immersive experience so that they'll be able to understand each other and work together. These are the two things which has actually worked for us. So I would encourage others also to try it out.
Sure, sure. Thank you, Dr. Venugopal. Professor Krishna, I'll come to you. What would be some of your recommendations today when we're talking of building and sort of not just building, but ensuring that there's a thriving collaboration between industry and academia? What are going to be some of your recommendations?
Well, I don't have per se a recommendation. I think what Professor Venugopal said is pretty, I mean, I do agree broadly or even at the details with him. But I think what we need to also understand is the Indian academia, we do not have what I would call as, if you look at the Western academia and the way the research projects happen, is the professor is almost like a CEO, and he has a very well-established pyramidal structure of postdocs who are the ones who are talking to the industry, and then there is this PhD students who are also working on the industry problems and also doing the research they publish. And the research problem today is posed often in autonomous driving. If you look at Uber and Waymo, they're publishing, and they're doing a real hardcore research, which is on the vehicle, integrating sensor data. But and then there is the grad students who are contributing to this development, and the undergrad student. Okay, so this pyramidal structure, for good or for bad, has worked very well abroad. In India, I mean, like, we have a very flat thing. So there is a professor and there is the industry, and we have a lot of undergrad students often who are working on it. And the students are constantly on the move. So I used to pose this question to my own students. Look, we have a self-driving car, we have LiDAR, we have cameras on the car. Why are we not wanting to work and drive the car around and get data and dirty our hands with it, right? So this the constant trouble, I think, with the Indian ecosystem is also that the student always wants to go abroad. Like, he is not thinking of the Indian university as the final parking place for him, where he can spend 6-7 years, do great work. So if the student is coming only to work for a year, and the industry gives us a problem, so often we are in the constant anxiety of how to maintain. If you have a 2-year project, and if you have people moving out, which often the industry also experience as faculty, we also have this problem of student moving out very fast, and they want to go abroad, or the tents are not firmly pitched here. And so when we take up a project with, suppose somebody says, can you do a 100x project? I would wonder, do I have someone, 3 people with me who will say, sir, I would be with you for next 5 years or 4 years? Unless if everybody is going to say, I'm going to be with you for 6 months or 1 year, then we are also under this anxiety of, are we allowed to fail on these 10x projects? Are we allowed to move 4.5x And would we still be appreciated, or do we need to do 10 or 100 and only then would we be appreciated? So this is an ecosystem which needs to change, wherein we have really competent people who are going to work with the faculty and the industry on this problem and deliver. From the academic side, I agree with the way Latha had put. So while we do a lot of research, it is somewhat publication driven. So if you have a thesis, then we want a publication in a top forum, and then it gives you a lot of visibility. It gives you a lot of added advantage. You go abroad, you are in that clique of top researchers, and you're going to talk to Raquel Oterson or Sanya Fiedler, and the top guys in Facebook AI research and OpenAI Drive.ai. And that's what the student is. So student is thinking of the professor. Hey, he gives me a top A+ conference, and then I leave. And in the academia is also encouraging that kind of work, while it also is very aware and is encouraging industry kind of work. So what we also need from the academia is to say, well, if a problem has been done for on a funded project which is delivered and code has been transferred and people are using that code in the industry, there is constant interaction, then that project, even if it is not providing any publication, it is worthwhile. Then the student is not anxious. So often we find that the student, when we work on a research or on an industry provided problem, the student is saying, sir, when would you allow me to work on the research problem? Because this is, I have my anxiety for submitting the thesis, and my parents want me to go abroad or get a job. Whereas you are asking me to work more and more on the problem which the industry is doing. And how do I manage? And here, the faculty is alone. This anxiety of the faculty, he is alone. He does not have a HR team who is going to solve this problem to him. He is the direct interface. So he plays the role all the way from hiring, training with the peer group, talking to the industry or weekly, also guiding on research and teaching. And he has multiple masters. So he has to deliver at the teaching side. He has to deliver at the thesis side. He has to deliver with the industry. He has to keep the students happy, and he has to pack off the students on time. And no one is aware that he is actually juggling with multiple balls. And there are different masters for him. We are responsible for the funding agency because that is what is driving the lab. We are also responsible for IIIT, because we have to publish. And so this is a kind of an ecosystem which the faculty often cannot expose this vulnerability. Latha comes and talks to me face to face. I'll say, hey, I'm great. That's what we have to showcase ourselves, right? I mean, this is an anxiety which we need to remove from the faculty. If you have to deliver 10x, 100x, we need to have people who are going to work with us with Dr. Venugopal or Latha or Rashmi, with whom we have been working with MathWorks. So we need people who are going to say, we are going to be with you, sir, for next 3-4 years, and we are willing to take up this problem and work with you, and will support this collaboration. And this is difficult for us to expect from a student, because the student is not thinking of IIIT or IIT or maybe as the final parking lot, and often is also because we lack the PhD bench strength, which often abroad people have. You have the best students move there, and that we don't want to get into that. But if this is also being resolved alongside, then a lot of this we would also be brave to take up this exponential thing, and not look at it as the way, like often we look, well, this problem funds the lab and I can do this problem because I've already solved the problem. And I know with my students, with not too much taxing of the students, so he can do research, he can work on the problem, he can deliver to the industry, and everyone is happy. This is the mindset is a bit incremental. If you want to move to the 100x mindset, we need a system which allows a bit of failure, not that we don't do anything at all, but also a system where we are able to organize ourselves, where people are going to work with us for a prolonged period of time. Yeah. Sorry.
Professor Krishna, I think that's a very, very valuable point that you brought up today in this discussion. Of course, we're talking of collaborations, we're talking of how industry and academia can come together, but ensuring that you have students ready to take up projects, ensuring students stay invested in research, in projects for the long run is equally very, very, very important. We have run out of time, but what I'm going to do is there are a couple of questions that we've received from our delegates. So quickly, allow me another 5-7 minutes. I'm going to take a couple of questions. The first, yes,
I just want to briefly touch upon for one aspect which is being discussed. So I just don't want to miss it.
Sure.
I really empathize with Professor Krishna as to it is a challenge for him to have student retention for the academic institute, and hence we are not able to deliver what we need to do because the funding agency expects. So my thought is that why doesn't academic institute have industry sponsored chairs or researchers who are on the payroll of industry, and they have to work in the university for a period of 4 years, 5 years till they deliver the project, from concept. And so this way, what will happen is, one, to ensure the employability of that person. Number two is that the industry has a talent which is being groomed. And number three, that talent can go back to the industry and then, train rest of the people. So kind of a paid internship program through the industry sponsored program is number one. Number two, even government is realizing that we don't have a student engagement program in the industry development. So if you have seen recently, there's a lot of push being done by government to have industry internships. We have been asked to have interns, internship program to be created for students. And the government has asked us to pay. It is going to be a paid internship program. So there are 6 institutes under the Department of Heavy Industry where the internship programs are being run. Unfortunately, because of COVID, we tried to do a virtual internship. We did not get very good response. It's not only we, but even the other institutes also did not get. The student expectation is very varied. I think it will be very important if academic institutes, like in other countries, have internship programs for one full semester, 6 months, 4 months, in an institute or an industry, for which they do get a grade point. So it will have 2 benefits. One is you are preparing an industry ready engineer. Secondly, you are ensuring that the technology development happens at the academic institute or at the industry. So it will be both ways. One is an industry sponsored research at the academic institute. Other is an internship program having in industry or in institutes like ICAT, wherein one full semester the student has to mandatorily spend on an industry project. And the industry should be throwing the projects problems. For example, on ICAT Aspire portal, that they want interns to work on this list of problems. And at the end of the day, the report will be sent back to that particular industry who has posed the problem. So it will be a very good means and tool of engaging students into the research, and also academia and industry bringing together. That's what I wanted to say.
Thank you. Thank you.
Yeah.
Latha,
can I just add on to it? Yeah, I have the point. I just wanted to add on to it. I think good that Ms. Tikku told it. Exactly the same point. I think we had tried this of having people with us half a year doing an industry project, and it was extremely successful, and the retentionship of the people who worked were also very good. So I think they were kind of, they also knew the culture of the organization, the different opportunities and so on. And most of them actually stayed back for much longer time as employees. And there was a very good win-win situation for, both parties. I think thanks for bringing that point. I think there's a very good model that works, rather than having people for 1 month or 2 months complete semester, in the industry, getting partly evaluation also done by the industry specialist along with the, the faculty. I think it really actually works.
Thank you. Thank you very much, Latha. Truly appreciate your, your perspective on this. I'm going to take 2 questions before we close. One is, let me read that out. That is by Vikas Arora. So Vikas, it's a slightly longish question. It says, everywhere we are hearing shortage of semiconductors, right? So integrated circuits are basis for autonomous, electrified, and connected vehicles. It is affecting technological development and causing difficulty in meeting timeline for mechatronic systems. In your opinion, what can be done to improve the situation? Who would like to take that? Dr. Venugopal?
Sure. There are two parts to answering this question. One is managing the global supply chain. And a lot of the semiconductor chip challenge was primarily because during the lockdown, when the automotive sales came down, the automotive industry thought that they would need these chips immediately. And so the semiconductor industry shifted to consumer products, and then they started making those chips. And for them to revert back to this, it was a 6 months lag was there. So that was one kind of problem to address. The second is something deeper, which is more of a R&D and a technology issue. The kind of chips that we would need for autonomous vehicles specifically, these are not the regular chips. These are very specialized chips. And the trend is now for a lot of the OEMs to design and make it themselves. And the material is also fundamentally different. These are not silicon chips. These are silicon carbide chips, which can take higher voltages, higher switching frequencies. So we are talking about something very, very different. And it's very important for us to recognize what are those chip designs and materials that we should place our bets on. And if needed, we should start doing it on our own. And this is a fairly new area, even for the very well-established, the famous chip manufacturers. For them also, it's new. So we can very well try to do it ourselves here so that we'll be self-sufficient in these areas. So these are the two parts to responding to this question.
Sure. Thank you. Thank you, Dr. Venugopal. My next question is, and this is by Abhijit Singh. He wants to know, considering India has all the necessary parameters to lead the future of mobility, be it skills, technology, domestic demand, and even funding, why is there a noticeable gap of opinion between the industry and government of India? Who would like to take that? Anyone, please. Latha?
Yeah, I think we partly covered it. I think it is I would say that there is some kind of a communication gap which exists. Yeah, the industry also has to make certain statements on what is the kind of the roadmap that we need to do and align with the, with the government as well as the research institutions. I think we need to come together more often, not only for this panel discussion, but, in the real life, I think we need to come together more often and discuss what are the issues that we have, what are the roadmaps that we need to do, and how to take our country forward. These discussions, unfortunately, are not really present. I mean, sorry for being critical, but I think it is not there at this point of time. And unless this is there, I don't think that the scaling up as well as the speed that we are looking at, I don't think that we can ever achieve it. That's my view.
All right. Thank you. I'll take a final question, and this is something, this has been a standard question here by a few. So people are interested to know, Rashmi, MathWorks, how can really MathWorks sort of help promote such collaborations? What role can you play?
Sure, Deepangshu, happy to answer that. So I think a lot of these threads were already discussed, but I'd probably take a few examples. I completely agree with Latha and with Pamela ma'am that, they are happening probably far too less and we need to scale it up. But nevertheless, I can quote a few examples. Now, we spoke about curriculum focus. So I can talk about one example between NIT Calicut, Bosch, and MathWorks, where we basically came together as a tri-party, three people in the ecosystem to develop a curriculum around system engineering. So we'd be happy to do that with, more industry and academia, because as I said before, we play a common thread and we can help there. We have a team, what we call a student competition inside MathWorks, right? So I think we spoke about how education has to be less theory and more practical. So all these student competitions that happen, be it the Robocon or the SAE Baha or the Supra SAE, we basically have people who not only mentor but also provide the tools, free of cost, so that these teams can basically learn, dabble with the real parts. And here we are talking about building a vehicle in 6 to 9 months. So they actually talk about concepts like cost analysis, endurance, and so on. And they're very quickly picked up by industry at the end of these competitions. Again, very happy to sponsor more of these. I know ICAT is doing something on similar lines. And for tier 2, where they can't get their students to build a vehicle because of whatever reasons, we can do this in simulation so that, they learn that much more and as close as you can get to a vehicle prototype. We have a startup program which also covers corporate accelerators. Again, here I can probably take the name of Bosch DNA because it's out in the public, where we work with the ecosystem of startups. Pamela ma'am also mentioned that we're also working with ICAT on that. Not just giving the tools and examples, but also mentorship, which is very important for them to learn concepts and basically build on that. One thing I'd like to mention maybe is a very recent sort of initiative that we have taken, which is called Excellence in Innovation. We spoke about giving students projects. So what we are doing is collecting a data bank of problem statements, which can be, the goal is that they do this over a particular semester. They are industry relevant problems. Today, of course, it is the team within MathWorks with the experience we have that is putting together these problems. But we are more than open for industry to also, contribute to this. And the goal is that we take this also to industry bodies, to innovation platforms like maybe Aspire, put these as grand challenges and help students to basically experience what the industry is thinking about and have a chance to solve them. So these are some of the ways, Deepangshu, where we are collaborating with the ecosystem, and happy to do more of that.
Sure. Thank you. I'm going to take one final question. This is by Raghavendran PR, wants to know, can industries really come up with any plan to notify academia about the projects that can be collaboratively done by the industry and academia together? So can there be a mechanism created where, the academia comes to actually know what are the kind of programs or what are the kind of challenges that the industry is actually looking at addressing? Ms. Tikku, Dr. Venugopal, please feel free to answer that.
Sure. In the last 1 week, I have seen this communications happen, where from the scientific advisor to the Prime Minister's office, these communications have been sent to various IITs, IICs, and top universities, where they have shared a list of problems of interest to different industry. For example, the Mahindra list had about 10 problem statements across mobility, farm tech, clean energy. So this scientific advisor to Prime Minister's office, that team had actually reached out to different industries, gathered list of problems of interest, and sent that to various academic institutions. I think this is a great start. And I started getting so many calls from professors to say, we want to respond to this, what is this and what is that? So there was a lot of momentum around it. I think ideas like this will really make it very effective. This is what I've seen in the last 1 week, very intense activity around that.
Very interesting. Yes, Ms. Tikku.
Yeah, Deepangshu, I think what I can say is that Aspire can help in collating the industry requirements. So people can post what is the curriculum requirement for the academia that they need to work on, create special courses, and we can then present it to the academia or through the ministry so that they can notify respective institutes to develop a course curriculum relevant to that particular specialized skill. I truly agree that our curriculum, in the engineering colleges have not changed much, from the time that we have passed out to the time now people are passing out. The same books are being taught, the same curriculum is taught. It's not being modified much. It's high time that we realign our curriculum in colleges. Maybe there are certain center of excellences like Professor Krishna's where they have focused robotics, but 98% of educational institutes are continuing with the same curriculum. So they need to change. So there has to be a special thought process given in what kind of curriculum we need to have in educational institute so that they are relevant to the industry in the present context.
Sure. On that note, I'm going to close this discussion. This, of course, can continue for longer, but thank you, ladies and gentlemen, for being part of this wonderful discussion. I thoroughly enjoyed interacting with you, and I hope you had a meaningful interaction as well. Thank you very much.
Thank you. Thank you, Deepangshu.
Thank you, MathWorks, and thank you, Deepangshu, Mobility Outlook, for putting up this great panel discussion. Thank you. We enjoyed it.
Appreciate it. Appreciate it. Thank you.
Thanks.
Bye.